Welcome back. I'm Muggsy, and today I'm going to explain how to name covalent compounds. Before I explain how to name covalent compounds, you should know what covalent compounds are and how to make the chemical formula for covalent compounds. And you should probably know about ionic compounds and how to name ionic compounds. So, assuming you know all that, let's get started. If I have magnesium and chlorine, how many ways can I put them together? Well, if we were to just look at the charges here, magnesium has a +2 charge, chlorine has a -1 charge. So in order to balance these charges, we're going to need 1 magnesium and 2 chlorines. So we're going to call this MgCl2. And that's kind of the only way we could do this. If we only had 1 chlorine, the charges wouldn't be balanced. So MgCl doesn't work. If we had 3 chlorines, they also wouldn't be balanced. We'd have too many anions in this case, so there'd be no MgCl3. We could, I suppose, have 2 magnesiums, Mg2, and then 4 chlorines, Mg2Cl4, but basically that would simplify down to just the same as MgCl2, because if we divide both those by 2, we just end up with MgCl2. So that wouldn't matter either. Because ionic compounds have balanced charges and they exist in these giant crystal lattices, there's really only one way of putting an ionic compound together. And because there's only one way of putting an ionic compound together, you really only need to give it one name. So we would just call this magnesium. We just say the cation as is, and then chlor, and then give it that "ide" suffix, magnesium chloride. And when you say magnesium chloride, I immediately know MgCl2. I don't think it's MgCl because that doesn't exist. Same thing with MgCl3. There's only one thing it can be, and that's MgCl2. So we don't need to mess around with any other special modifying words that tell me that it's 1 magnesium and 2 chlorines. Now with covalent compounds, that's actually out the window because there's lots of different ways of putting them together. Let me give you an example. Let's say we had the element carbon and the element hydrogen, right? Here are just a few different ways we could put that together. We could have 1 carbon surrounded by 4 hydrogens. We could have 2 carbons surrounded by 6 hydrogens. We could have 2 carbons again, but with a double bond surrounded by 4 hydrogens. We could have 2 carbons yet again, but with a triple bond surrounded by a hydrogen apiece. And this will just go on forever. In fact, there's probably something like infinite ways we could stick carbon and hydrogen together. So we can't just call this, for example, carbon hydride, because this could also be carbon hydride, and so could this, and so could this. So we're going to need some kind of way of letting the people that we're talking to know what these things are. We can't just call them all carbon hydride, because there's lots of different ways we could stick hydrogens on carbons. There's really only one way we could stick chlorines and magnesiums together. So with covalent compounds, we need to use prefixes. I would call this carbon tetrahydride. I would call this dicarbon hexahydride, dicarbon tetrahydride, dicarbon dihydride. Now, that was a lot. We'll get into that right now. Earlier, you heard me refer to this, CH4, as carbon tetrahydride. Let me explain how I got there. You start with whatever's first in the chemical formula. In this case, it's the carbon. And just like with naming ionic compounds, we don't change that at all. So carbon's first, we just say carbon. Then we say what comes last, and in this case, it's the hydrogen. And we do just like we did with ionic compounds. We replace the last syllables with "ide." So instead of hydrogen, it just becomes hydride. And then we use one more thing. We have this little prefix here, tetra, before hydride. Tetra means 4, which is our way of saying this is 1 carbon and 4 hydrogens. And that's because, as I showed you earlier, with covalent compounds, there's all kinds of different ways of putting them together because we have things like double, triple bonds, coordinate bonds. We can make big chains of them. So we're going to need ways of distinguishing amongst all the different versions of compounds with carbon and hydrogen, for example. Okay, now this tetra is something you're just going to need to memorize. It's your basic number prefixes, and I'll write them down right now. So going from 1 to 10, for 1 we use the prefix mono. Mono meaning 1. If you're from a monotheistic religion, you have one God. If a monopoly controls the oil, then that's one company that controls all the oil in the country. Mono means 1. For 2, we use di. This can be a little bit tricky because a lot of people want to use bi for 2, and we do use bi in science, but for chemistry in this particular example, we use di instead of bi. So if it was 1, let's say sulfur and 2 hydrogens, we would call that sulfur dihydride. 3 is much easier, tri. A tricycle has 3 wheels. A triceratops has 3 horns, etc., etc., etc. A triangle has 3 sides and 3 angles. 4, as you saw earlier, is tetra. You're probably less used to tetra than you are to mono and tri, but you could think that what is it? Is it a tetragon is a shape with 4 sides? Is that right? A tetrad is a group of 4. Specifically, it might be 4 chromosomes. Those are called tetrads. Tetris. If you've ever noticed in the video game Tetris, all of the shapes are made of 4. So the square is made of 1, 2, 3, 4. The big long one, similarly, is 1, 2, 3, 4. And then there's all the different variations, right? So there's this one. 1, 2, 3, 4. So each of the pieces in Tetris are made of 4. 5 is penta or pent, because a pentagon has 5 sides. The Pentagon, the building, has 5 sides. 6 is hex or hexa. A hexagon has 6 sides. 7 is sept. There's a lot here. September used to be the 7th month in the calendar, and October used to be the 8th month, oct. And November used to be the 9th month, non. But then they readjusted the calendar, so now that's not quite the same. But know that sept means 7. If you read Game of Thrones at all, they have a religion with 7 gods, and their churches are called septs. Oct is easy to remember for 8. An octopus has 8 legs, an octagon has 8 sides. Non, I don't know what non examples there are, but know that non is 9. They sound similar, non, 9. And then 10 is deca. A decathlon is 10 events. A decade is 10 years. There's so many decas. Okay, so you're going to have to memorize these prefixes. Now, many of you probably already have them memorized because they show up in a lot more places than just chemistry class. But if you haven't yet, go ahead and take the time to memorize all these different prefixes. It'll be useful, I swear, not just in your chemistry class, but in your other classes as well. Biology, anthropology, they show up all over the place. For instance, if you've gotten the disease mononucleosis, you want to guess how many nucleuses that is? Right, it's 1. These will pop up all over the place. Okay, I'm going to teach you how to name covalent compounds by just going through a bunch of examples. So let's start with N2O. Now, if this were an ionic compound, we would call this nitrogen. We start with the first thing in the formula. Then we do the second thing in the formula, and we give it the "ide" suffix. So this would be nitrogen oxide. And that's because with ionic compounds, there's there's only one way of putting the compound together. With covalent compounds, as you can see, there's a couple different ways of putting nitrogens and oxygens together. We could have N2O, we could have N2O4, there could be N2O5, we could just have NO. There's many different ways, so we need to use our number prefixes to tell you exactly how many nitrogens and exactly how many oxygens there are in this molecule. So, since there's two nitrogens, we're going to call this dinitrogen. And since there's one oxygen, we actually do need to use a number prefix. We use 1 for mono. We would call that monoxide and not nitrogen oxide. That would be if it's ionic, and it's not, it's covalent. These are both nonmetals. And there's one more problem with this. So far this looks pretty good. I guess that N shouldn't be uppercase. Dinitrogen monoxide. Notice we've got two O's stuck together and they sound kind of awkward, monoxide. And in English, we don't like to stack these vowel sounds together. Two O's typically would be an oo sound. So what we're gonna do is if we have two O's stuck together or an O and an A stuck together when we put these prefixes on, we're just gonna remove one of them to make it sound a little tighter. So instead of dinitrogen monoxide, we're gonna call this dinitrogen monoxide. Remove one of those O's and it sounds a lot better. Dinitrogen monoxide. Beautiful. Okay, you'll get the hang of these rules as we move along. Okay, second one, we're going to follow the exact same rules. We're going to start with nitrogen. We're going to write out the full element name, nitrogen, and there's two of them, so we're going to write dinitrogen, just like we did for the first one. Dinitrogen. But now instead of monoxide, instead of one oxygen, there's four oxygens, tetra, so it's going to be dinitrogen tetraoxide. And exactly as before, when we put the number prefix on, we actually end up with two vowels together, an A and an O, tetraoxide, and it just makes the word kind of awkward to say. So we're going to remove the A this time and just leave the O, and we're going to get dinitrogen tetroxide. So if there's two O's, it just becomes an O. And if there's an O and an A, it also just becomes an O. That's really the only kind of change you need to make when you're putting these number prefixes on. Let's do the next one now. One carbon and two oxygens. So I think I might make a mistake here. Actually, okay, I'll do it, yeah. So one carbon, that's monocarbon. And two oxygens, dioxide. Okay, the mistake I made is, even though we have one carbon here, if it's the first thing in the chemical formula, we don't need to use the mono prefix if there's one of them. We'll just assume, if I wrote carbon, that there's one carbon. And so we call this carbon dioxide. And we're just going to assume that if there's nothing else there, if it's not dicarbon or tricarbon or tetracarbon, that it's just going to be one carbon. So it's a way of kind of saving time. If there's just one thing and it's the first thing in the chemical formula, you don't need to use the mono prefix. If it's the second thing in the chemical formula, like with N2O, you actually do need to use the mono prefix. So the first thing in the name, the first element, if there's just one of them, you don't need to use the mono prefix. Okay, next, C3BR8. Okay, so I'm gonna do it again, carbon, octabromide. And, oh, looks like I made another mistake. Okay, in the last one, we were able to just write carbon instead of monocarbon because you don't need the mono prefix if it's the first thing in the chemical formula. But if it does have a number of things, more than one, if there's 2 carbons or 3 carbons or 8 carbons, you actually do need that number prefix. So I can't just write carbon octabromide, I have to write tricarbon octabromide. And these are technically 2 words, it's just kind of hard to see. Okay, so first thing in the name, if there is more than one of them, you do need to use your number prefixes, di, tri, etc. Okay, here we've got 1 bromine and 3 chlorines. So I'm going to call this monoboron, trichloride. And oops, I made another mistake. Did you catch it? It's the monoboron. If it's the first thing in the chemical formula, like this boron here, and there's one of them, you don't need to use a number prefix for mono. So this is just boron trichloride, not monoboron trichloride. Next one down, calcium and fluorine. 1 calcium, 2 fluorine. So I'm going to call this calcium difluoride. And would you believe that I made another mistake? This one's actually a really tricky one. I threw this in here just to kind of mess with us. Calcium is a metal and fluorine is a nonmetal. So calcium fluoride, unlike all these other compounds, isn't a covalent compound, it's an ionic compound. Remember, a metal and a nonmetal is ionic, 2 nonmetals, that's covalent. So with ionic compounds, we don't need to use the di, tri, etc. This would just be calcium fluoride. And why can we just call it calcium fluoride? That seems strange. Well, unlike these other ones where there can be different numbers of each element, calcium fluoride exists in a crystal lattice structure in which there can only be 1 calcium to every 2 fluorines in order to make the charges balanced. Because calcium has a +2 charge and fluorine has a -1 charge, so you're always going to need 2 fluorines to that 1 calcium. So if you have calciums and fluorines, it's never going to be CaF, it's never going to be CaF3 or CaF4 or C5F. It's always going to be CaF2. Okay, calcium fluoride. That was a trick one because it's ionic. Trick question. Okay, next we have P4O6. I'm going to stop making mistakes. If there's more than one of them, we do need to use the number prefix, and there's 4 of them, so we're going to call this tetraphosphorus, 6 oxygens, hexoxide. Now you might say 6 is hexa, so why isn't hexaoxide? Because that just sounds awkward. And remember, whenever there's an O and an A, we drop the A and just make it an O. So instead of hexaoxide, it just becomes hexoxide, and it flows off the tongue a lot more easily. Okay, for this bottom one, we have 1 carbon and 1 oxygen. So you might be tempted to call this monocarbon, but remember, if it's the first thing in the formula, you don't need to use a number prefix, so we're just going to call that carbon. For the oxygen, we do need the number prefix because it's not the first thing, it's the second thing in the chemical formula, so we're going to call this monoxide. Again, you might put mono and oxide together and say monooxide with 2 O's, but whenever there's 2 O's, it just becomes 1 O, because monooxide is really awkward to say. Monoxide flows much more beautifully. Okay, so those were a lot of examples. This one was a trick one, but just remember the rules of naming covalent compounds. I'll go over them again real quick just for you. Just like ionic compounds, you start with the first element in the formula. You write out the full element name, nitrogen, carbon, boron, etc. If there's more than one of it, you use a number prefix, such as with dinitrogen or tricarbon. If there's only one of it, you just use You don't use a prefix at all. Carbon, boron, carbon. For the second thing, or third thing in the chemical formula, you do need to use the "-ide" suffix, just like we did for naming ionic compounds. And you also need to use, all the time, the number prefixes. Even if it's 1, you're going to use mono for that one. If you end up with a bunch of vowels stuck together that sound awkward, like monooxide or tetraoxide, we tend to remove one of those vowels and replace it with just, so that we just have an O left over. So dinitrogen monooxide becomes dinitrogen monoxide, and dinitrogen tetraoxide just becomes dinitrogen tetroxide. Okay, those are your naming rules for covalent compounds. They're pretty simple. I think the more you practice it, the better you'll be at it. Earlier in this video, you heard me call this carbon tetrahydride, 1 carbon, 4 hydrogens. In reality, we actually call it methane. This, you heard me call dicarbon hexahydride, 2 carbons, hexa, 6 hydrogens. In reality, we call that ethane. This one we call ethene, and this one we call ethyne. Likewise, if you have 1 oxygen and 2 hydrogens, we don't call that dihydrogen oxide, we call that water, right? So in chemistry, you're going to run into a lot of common names and other naming systems beyond this one that you just learned. Just keep an open mind as you kind of go through these compounds. Because as you learn more and more in chemistry and you get into things like organic chemistry and biochemistry, you're going to learn all kinds of different ways of naming covalent compounds. This is basically just the foundation that you're going to start building your knowledge on. If you told me you had carbon tetrahydride, I'm used to hearing that molecule called methane, but I would still know basically what that is if you said it that way. So there's still some utility in learning the method that you just learned, but just know that as you go on in your chemistry journey and you learn more and more and maybe become someone in the medical field or a chemist or a teacher or any of these things, you're going to learn all these other ways of naming these covalent compounds, especially specific classes of covalent compounds. So just keep that in mind. Okay, once again, I'm Muggsy. It's been a pleasure talking to you today. I'll see you next time.